Good morning, everybody. I hope you guys had a great weekend and you were able to enjoy the weather on Sunday at least. Saturday it was a little cold, but it was still nice out all weekend. Today we're going to continue working in Unit 5, which is all about circles. So on Friday or Thursday, whenever we met, you guys had the opportunity to catch up on some of your missing assignments and to complete an extra credit assignment. If you still want to work on that, I'll give you guys until the end of the week to submit the extra credit. So we're going to start off with a little bit of a review of what we went over last week, and that had to do with central angles and arc measures, okay, measures of arcs. So we're going to do numbers 8 and 9 as just kind of a little review. So I gave you guys some tips in the video that I posted either Thursday or Friday, and basically you either look at the circle as a whole, which is 360 degrees, or as a half, a semicircle, which is 180 degrees. So anytime you have a diameter, I kind of like to try to look at the half circle. So for example, here we have a diameter, okay, at JL. Therefore, JKL is half of a circle. So the measure of arc JKL is 180 degrees. Okay, because it's half a circle, it's a semicircle. Now, arc JKL is broken up into two arcs. The measure of arc JK and the measure of arc KL together create that semicircle, which is 180 degrees. So all you have to do is add up the two labels, set it equal to 180, and we're going to solve. So combining like terms, we get 22x minus 18 equals 180. We get 22x equals 198. And then solving for that, we get x equals 9. Okay? All right. So now that we know that x equals 9, I'm going to erase this marking a little bit so it can help us. We can find the measure of arc JK and the measure of arc KL just by substituting in those values. So if we did 5 times 9 plus 23, that would give us 68 degrees. And then you could either subtract that from 180 or you could just plug it back in. If we did 17 times 9 minus 41, that would give us 112. Okay, so now if you notice, we've got some vertical angles going on here. All right, so at N, JNK, okay, angle JNK is congruent to angle LNM because they are both vertical angles. So therefore, this is also 68 degrees. And then we've got the same thing going on here with 112. So now let's just fill in the rest of our answers. The measure of arc JK is 68 degrees. The measure of arc MJ is 112. And the measure of arc LMK. All right, so L to M and then all the way around to K. It's LM, MJ, and JK. We could just add those three up. When we add them all up, we get 248 degrees. Okay? All right, so looking at my next problem, I don't see any diameters in here. So I'm not going to be able to look at just half of the circle. I have to look at the circle as a whole. So it looks like our circle is broken up into arc VW, arc WX, arc XY, and arc YV. And that's the whole circle, so it's equal to 360, okay? So we've got labels on almost all of them. VW is 8x. WX is 21x minus 12. XY is 10x plus 9. And then VY or YV doesn't have a marking or a label on the arc, but the central angle is labeled as 90 degrees, and that would be congruent to the measure of the arc, so plus 90 equals 360. When we combine our like terms, we get 39x plus 87 equals 360. 39x equals 273 when we subtract our 87. And then divide by 39, we get x equals 7. Okay, so my value of x is 7. So now I'm just going to go in and I'm going to plug all of that information in. 8 times 7 is 56. 21 times 7 minus 12 is 135. And again, I just did this on the calculator. I'm not doing it that quickly in my head. And 10 times 7 plus 9 is 79. And then we have 90 over here. Okay? So now we just can go in, fill in our answers. We might have to add some arcs together depending on what they're asking us for. So the measure of arc WX is 135. We have that one. YW, okay, so we don't have YW. We're going to have to add 2 together. Y to W would be 90 plus 56, which is 146. YX we have, that one is 79. And then we have VXW. So V to X and then all the way around to W. We can add up the 90, the 79, and the 135, and we get 304. Okay? So the arc measure is just what portion of the full 360 degrees does this circle take, does this chunk take up, okay? What part of the circle is it? How many degrees out of 360? And that would be the same no matter what size the circle is. And I kind of covered this the other day. So if we still had in number 8 the same circle with a central angle of 112, but it was a lot smaller. So let's say we had a much tinier circle, but my central angle was still 112. This arc measure would still be 112, even though it's a lot smaller, because it's still 112 degrees. Arc length is something different. It's a portion of the circumference, and the circumference is going to change when the circle gets bigger or smaller, okay? So even though this arc measure is 112 and 112, the arc lengths are different because this circle is a lot smaller than this circle, okay? So arc length isn't too bad. We just have a formula for it. The length is equal to, and it's going to have variables, but we'll go through them in a minute, X times C all over 360. So X is the degree measure of the arc or the central angle, depending on what they give you, and C is the circumference. So you're going to need to figure out the central angle or the measure of the arc and also the circumference before you can solve for the arc length. All right, so we're going to do the evens, and then you guys are going to check your answers with the odds once we are done with the evens. All right, so here we go. So we need the degree measure of the arc. So if EB equals 15, find the length of CD. So this is what we're looking for here, all right? So I need this central arc. I need the measure of arc CED, or the measure of angle CED, I should say. So the measure of angle CED is going to be 180 minus 68, okay? Because we've got a straight line here. That's our diameter. And we get 112 degrees, okay? Now we need to find the circumference. The circumference is equal to either 2 pi r or pi d. They give us EB, the length of EB, which is a radius. So we're going to go with 2 pi r, 2 pi times 15, which is 30 pi. Okay, now we're going to find the measure of that arc length. L is equal to 112 times 30 pi all over 360. And you guys are going to actually plug, if you want to, you could plug pi in. I'm going to round all of my answers, so I am going to plug pi in. So we would get 3360 pi over 360, and that is about 29.3 centimeters. Okay? All right. Number 12. They give us the length of VS as 12, and VS is a diameter. Okay, so let's find the circumference first. So the circumference is, we're going to use pi d for this one because they gave us the diameter. So circumference equals pi times diameter, and in this case, it's just 12 pi. Okay, they want the length of arc UT. So we need to find that angle measure in there. So if I look at what I have that angle UWS is vertical to angle VWR, okay? Now, I know then from here all the way around to here would be 127. But again, I only want that little arc UT. This one is 90, okay? TS is 90. So I can just do 127 minus 90 in order to get my value for X. So X equals 127 minus 90, which gives me 37. Okay, so now to find my arc length, L is equal to 37 times 12 pi all over 360. And we get 444 pi over 360, which is about 3.9 meters. Okay, and since it's a length, we're going to use a unit of measurement. All right, last example that I'm going to walk you guys through, and then you're just going to try the other three and check your answers. FG is 27. So let's see, FG, they give us a radius. So in order to find my circumference, it's 2 pi r. So 2 times pi times 27 is 54 pi. So my circumference is 54 pi. They want the length of arc FED. So I need to find all of this, FED. Now, if you notice, we have the measure of arc FCD would be 47 plus 80, which gives us 127. So we can just subtract 127 from 360 in order to get that X value. Okay, because it's the rest of the circle. We've already accounted for 127 degrees of the circle. We need the rest of the circle. So when we subtract that, that gives us 233. So now to find that arc length, length is going to be equal to 233 times 54 pi all over 360. We get 12,582 pi, big one, over 360. And then when we solve for that, we get 109.8 yards. Okay? Alrighty. Okay, so I want you guys to pause the video and try numbers 11, 13, and 15, and then come back and check your answers. All right, so here you guys have your answers for numbers 11, 13, and 15. Number 11 was pretty straightforward. We had vertical angles, so in order to find the other pieces of the diameter, we just did 180 minus 162. That gave us OP and MN. Or you could have just done vertical angles and then done 360 minus 162 to get 198. And then you just plug in from there. 13 and 15 were a little bit trickier to find the measures of the angles or the arcs, so that X value. For number 13, I looked at the diameter here, and I found the measure of angle HLI because it's a linear pair, so that one was 95. That angle is vertical with angle KLJ. And then we had all of the information we needed. We could just add up those 4 angles, and that gave us the X value. Plug in. And then number 15, again, a little bit trickier, but I noticed that we had vertical angles at PWQ and TWR. We already had part of TWR, it was 31, so to find the other part, which was TWS, which is what we actually needed, we could do 128 minus 31. That gave us that measure of 97. Oh, and I have a typo here, actually, so this should have been 97, not 197. 97. 97 degrees. There we go. And then the final answer is still right, though. I actually multiplied 97, but wrote 197. Okay? So if you guys have any questions, please just let me know. All I want you to do for credit for today's assignment is just submit your notes. You will have a quiz tomorrow, but you'll be able to use your notes on the quiz. Okay? So again, let me know if you guys have any questions. Just shoot me an email, and I will chat with you guys next class.